this video about ions. Hey, lose an electron lately? You better keep an eye on it. That might not be funny at all now, but get to the end of the video, go back, see it again, and laugh your butt off. Okay, what's the point of this video? The point of this video is to talk about what ions are and all about charge. So first, let's go back to something you've already learned, which is fundamental forces. We talked about there being 4 fundamental forces of nature. Those being the strong nuclear force, electromagnetism, the weak nuclear force, and gravity. And we said that they kind of have an order from strongest to weakest, where the strong nuclear force is the strongest and gravity is the weakest. So let's focus for a moment on electromagnetism. That's really a lot of what's going on in this video today. Electromagnetism, obviously as its name implies, involves electricity and magnetism, and it is the second strongest force of the 4 forces, and it's really the one that once you ignore the fact that we are stuck to the ground because of gravity, the one that we really deal with on a day-to-day basis, and that's all due to charge. So what's charge? Charge is a property of matter, a fundamental property of matter. So matter can be neutral, it can have a positive charge, or it can have a negative charge. And you may know from your dealings with things like magnets that similar charges repel. So if you take 2 positive charges like this, they're going to push away from each other. Just like if you take the 2 north ends of a magnet, they're going to push away from each other. And then opposite charges attract. So a positive and a negative, like the positive and negative of a magnet, will attract. They'll come together. And so the existence of these charged particles is what gives rise to the electromagnetic force. So we have particles, they have charges that are either negative or positive. They repel or attract depending on what they're near. And that's where we get the electromagnetic force from. And where does the charge get carried? It gets carried on subatomic particles. Remember, we have atoms, and atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. And so we get charges within these subatomic particles, and it's really what carries charges around. So protons are positive. So I think it's helpful that we've got the letter P involved. So protons are positive, right? Protons are positive. Electrons are negative. We don't have a good letter situation going on with that one, but electrons are just the opposite of protons. And then neutrons are neutral. See how they both start with the same set of letters. Neutrons are neutral. They have neither positive nor negative charge. They don't have charge as a property, whereas electrons have that negative charge and protons have the positive charge. So something to think about for a moment is, well, we already said that similar charges, like charges, repel. So a bunch of positive things together, they will push apart. Negative things together, they will push apart. And in the nucleus of an atom, we have neutral neutrons, which aren't doing anything charge-wise, and then we just have a bunch of positive protons. And why are the positive protons able to stay together in the nucleus and not fly away from each other and go attract themselves to the negative electrons out there? What's going on? Well, the key to that is to look again at the order of strength of our 4 fundamental forces. So it is true that there is an electromagnetic force that should be pulling these positive protons to the negative electrons and away from each other, but what is stronger than that? The strong nuclear force is stronger than electromagnetism. So there is a force holding the nucleus together, which is the strong nuclear force, right? It holds these particles together, and it's stronger than electromagnetism. That's why the nucleus of atoms stay together. And something important to know that, yes, electromagnetism is at work, but it is not stronger than the strong nuclear force. Okay, net charge. Net charge is something that we look at when we look at an atom. We want to know overall, when we balance out the protons and electrons, what charge does that atom have? And you can simply do it by this very little important little formula here. The net charge on an atom is the number of protons minus the number of electrons, and you do it in that specific order to get the charge correct. If the number of protons and neutrons is the same, if the number of protons and electrons is the same, the atom is considered neutral, and its net charge is 0. But if it has something other than 0, we call it an ion. That means there's an imbalance between protons and neutrons, and the atom as a whole has a charge of some kind. So here's an example for you. Let's take beryllium. Beryllium is atomic number 4. So it has 4 protons. Count them in the nucleus right here. 1, 2, 3, 4 protons right there. If this one atom happened to only have 2 electrons, and the electrons here are being represented by these 2 guys here, then it would be net charge. Net charge is protons minus neutrons, so that becomes 4 minus 2 is 2. And then we give it this symbol, 2 plus, because that's a positive 2. It's a positive 2, it's not a negative 2. So that's the only really complicated part about it, is you just have to remember what the sign is. So you can subtract things and end up with a negative result, and you have to keep track of that. But it's not complicated math, it is subtraction no matter what. So that should be fairly straightforward. And here's some terminology for you. Ions are either positive or negative. Obviously, if it's no charge, a charge of 0, it's not an ion. So it's either positive or negative. A positive ion is called a cation. And the best way to remember that is probably that cations are positive. Isn't this one so cute? Look at this cute. Got a pause, so it's positive. So anyway, cations, think cats, think positive. They're positive, okay? Right? And then the opposite is a negative ion, which is more electrons than protons, and we call that an anion. An anion. Cations are positive, anions are negative. Here's another example. Here's a fluorine atom. If you have a neutral fluorine atom with the number of protons and electrons balanced, it's got 9 of each, right? 9 minus 9 is 0. That comes out to neutral. But a fluorine anion, which is actually what you find most of the time, you don't find fluorine atoms with no charge out there, except under very strange circumstances. A fluorine anion has 9 protons and 10 electrons. So that means that its net charge is 9 minus 10, which is equal to negative 1, right? So you can actually write that as an F minus, right? Like, wouldn't that be the worst grade you could get? F minus, we don't write 1s because we just don't write 1s. We don't need to. If it was more than 1, we might write the number, but this is just an F minus. It's a fluorine ion, and that is actually the stuff that helps your teeth. So inside of your toothpaste is sodium fluoride, and when it dissolves in your mouth, those F minus ions hang around and they actually help your teeth repair themselves. So that's the connection between ions and your toothpaste. So what does it matter that we have ions? Well, ions actually attract each other because they end up with these opposite charges. So you'll have some kind of metal element will become a cation, so it has a net positive charge. And you'll have some non-metal element which becomes an anion, or a net negative charge, and then they'll attract each other. And they actually attract each other in these sort of nice, neat compounds called ionic compounds, and those are where these ions are stuck together through what are called ionic bonds, which are attractions between ions with opposite charges. So ionic bonds between cations and anions form ionic compounds. Here's an example of some ionic compounds that you might come across. So ionic compounds dissolve in water. It's one of their characteristics, and that actually allows us to get ions out of them that we might need. And so Gatorade, you might know, advertises a lot that it gives you the electrolytes you need. Well, what are electrolytes? Electrolytes are ions that can carry an electrical charge, and 2 very important ions for your body are sodium and potassium. So Na plus is a sodium ion, K plus is a potassium ion. And where do they come from? Well, if you look at the ingredients of Gatorade, you'll see it's mostly water, and then sugar and dextrose are both kinds of sugar. So there is a massive, massive amount of sugar in Gatorade. And then a little farther down, you're going to see sodium citrate and monopotassium phosphate. And those are 2 ionic compounds. So they are attracted to each other, but when you put them in water, they actually come apart into their individual ions. So you have a bunch of these sodium ions and potassium ions floating around in there that you then can drink down into your body. And why does that matter? Well, sodium and potassium are extremely important because they are used to create differences in charge that transmit signals from one neuron to another. So this is something that you will learn in biology. It's called the sodium-potassium pump, and it is how your neurons work, right? Not just the neurons in your brain, but all the nerve cells in your entire body transmit signals using sodium and potassium ions to create this pulse of electricity. So you need enough of those ions in your body to do things right, and if you run low, you may actually have some problems. One obvious one is muscle cramping. However, sports drinks are not necessarily what's needed for getting these ions. They are present in most of our foods that often don't have nearly the sugar of something like Gatorade. So those are ions. The things to remember are we're talking about charged atoms that have an imbalance of protons or electrons, and we can figure out what that imbalance is and calculate the charge by taking the number of protons it has, subtracting the number of electrons, remembering the sign, and there is your net charge. And you can find them in things like sports drinks, and they are necessary for things like, every nerve cell in your body. Okay, thanks for watching. See you next time.